Good morning, students. I welcome you all for another session on the course Computer Architecture and Organization. In this class, I am going to discuss about the concept memory interleaving. So, what is memory interleaving and what are the different methods under this memory interleaving and what is the advantage of this memory interleaving, that I am going to discuss in this class. Right, we straight away enter into the concept memory interleaving. What is memory interleaving is? Memory interleaving is a technique which divides memory into a number of modules such that successive words in address space are placed in the different modules. What is memory interleaving? It is a technique which divides our memory into a number of modules. Then successive words in address space are placed in different modules. So for better understanding, if you go for next slides, you may get a clear-cut idea. As of now, you remember memory interleaving is a technique which divides the available memory into number of memory modules, and the successive words in address space was available in different modules. You have to remember this. The main memory of a computer is structured as collection of physically separate modules, each with its own address buffer register ABR and data buffer register DBR. For example, my system needs some 64 kilobytes of memory. For example, your 64 kilobytes of memory is not available in a single chip. You make this 64 kilobytes of memory with the help of some 4 memory chips. Each memory chip size is equal to some 16 kilobytes. Each chip size is equal to 16 kilobytes. Then such 16 kilobyte size of chips I have to use 4 to make a total 64 kilobytes. Then what happens? I have total 65,536 addresses, which is equal to 64K. These addresses I split into 4 partitions. And each partition belongs to one module, that is one memory chip of size 16 kilobytes. The first half is here, and another half is here, and another half is here, and another half is here. This is just a simple meaning of this memory interleaving test. Here what I mentioned. And in order to access the information from each and every memory module, I took the help of a pair of registers. One is called ABR, means address buffer register, and second one is called DBR, data buffer register. I have 2 types of registers. With the help of those 2 registers, I can read or write information onto any particular location of a module. So that is this. The aggregated rate of a transmission of words can be increased. What's the advantage of this? The transfer rate, how fast we are transferring the information to the memory or from the memory, that can be increased once you have this concept used in our systems. So there are 2 types of memory interleavings. In that, the first one is higher order memory interleaving. What is a higher order memory interleaving? That means in this, the processor generates address. Higher order bits are used for selection of a module or name of a module, and the lower order bits of a generated address are used to select a particular word address in the module. I repeat, in this particular interleaving, the processor generated address, higher order bits are used for name of a module, that means the selection of a module, and the lower order address bits are used for selection of particular word in the module. So that's it. When continuous locations are accessed, only one module is involved. In this is a major problem here is, in this particular interleaving concept, if I want to access a successive locations information, I was enabled only one particular module, because these successive locations are available only in one particular module itself. This is a major problem of this particular concept, that is higher order memory interleaving. So we can go and see for better understanding by taking of this example. So here this is the total address. The total address of size k plus m bits. This address was generated by CPU, which you can assume as a main memory address. Out of that, some k number of bits. Out of that k plus m bits of CPU generated address, higher order k bits are used for selection of module. See here friends, this whole thing is my memory. This memory I split it into some k number of modules. This is module 0, this is module 1, and this is module 2. If I want to access any location of any module, I took the help of a pair of registers. One is ABR, that means address buffer register, and second one is DBR, data buffer register. So here I clearly told you that the higher order k bits of a CPU generated address are used for name of a module or for selection of a module. So that these bits are in parallel is applied to all the modules. For example, here I've gone place 0, 0, 0, 0. All these bits are 0. That can be received by all these modules. But out of these n number of modules, only this particular module is activated because this particular zeros is equivalent to 0. So that here this is selects this module 0. And these modules are not selected. Then with the help of remaining m number of bits, I am going to access the information from one particular location. Again here also this address in a module is applied to all the modules address buffer register. So this address is issued by this ABR and this ABR and this ABR. But out of all these things, only this module is active, so that this address is accepted by this ABR, and according to that address information and based on the control signal, either it will transfer the data to processor or it can receive the data from the processor with the help of this DBR. So for example, here I place again all these bits are 0, 0, 0, 0. That means here I would like to select the first location. I'm going to access the information from the first location of this module. And next here, least significant bit is changes to 1 and remaining all bits are 0. That indicates again only this module was active. I'm going to access the next location information of this module. And next I want this bit 0 and this bit is 1 and rest of the bits are 0. That indicates that I'm going to access the location third of this particular module. This is the first location, second location and third location. That means the continuous locations. If I want to access a continuous words from a memory, those are continuous words are belongs to only particular module, only one module. That means at any instant of time, out of n number of modules, only one module is active and remaining the n minus 1 modules are not active. This is the problem with the first method, that is higher order bits memory leaving. And to overcome this, I shifted to the second one, that is lower order interleaving. So what we did for higher order interleaving, exactly opposite we do in lower order interleaving. So, and here we clearly says that this particular method is more effective compared to the previous one. How it is effective? It is effective because in order to access the successive words from a memory locations, in that particular case, no doubt more than one module is active simultaneously. So that's why this second method of interleaving is more effective compared to the first method. So what we do in this? In the processor generated address, the lower order bits are used for name of the module or selection of a module, and the higher order bits are used for selection of particular word. So that is an important thing here. So that the consecutive addresses are located in successive memory modules. That means if I want to access a successive words from the memory, those words related addresses are not belongs to same module, those may be presented on at different modules. So see here friends, it gives some more idea to you. So lower order bits are used for selection of your modules, and higher order bits are used to select a particular word in a module. For example, here all these bits are 0, 0, 0, 0, 0. So that belongs to a first word here or here or here. That if my module address is again all zeros, that is activated this. And next one I want to access a next word, then least significant bits are changes. These are 0, 0, 0 and least significant bit is 1. Then that is belongs to this particular module. From this module again I was accessing first word itself. That means the successive words I was accessed from the memory from a different modules, so that at a time more than one module is in active condition, so that the transfer rate of data between a memory and a processor can be increases. So this is about our lower order memory interleaving. And accessing of consecutive memory locations can keep several memory modules busy at any one time. That's what I'm saying about the previous case. This results in both faster accesses to a lot of data and a higher average utilization of the memory system. As another advantage here, what we are adding is that is utilization of memory system. It is a higher average utilization of a memory system for memory interleaving concept. So that I hope you understand, friends, what a memory interleaving is. So here interleaving means simply we divide the available memory into different modules, and our aim is we have to go and activate multiple modules at a time. Due to that, I have to increase the data transfer rate as well as utilization of main memory systems. So for that case, we took the help of this memory interleaving concept. I hope you understand the concept of memory interleaving. In the next class, we will go and discuss some other important topic, that is semiconductor memories, that we discuss in next class. Thank you for patient listening.